Welcome to the SafeStrip project presentation. The project received funding from the European Union's Horizon 2020 program and the grant agreement number 723211. The SafeStrip project started 3.5 years ago with a competitive consortium of 18 partners, managed by Ertico and the Hellenic Institute of Transport from CERT. SafeStrip aims to introduce disruptive technology by embedding cooperative ITS applications into existing road infrastructure, utilizing low-cost integrated strip markers on the road for all road users and all vehicle generations. The project had 8 principal objectives. They are listed on this slide. The focal point of the solution is the so-called strip, an innovative platform of micro and nano sensors, communication and energy harvesting units, manufactured for the first time, replicated, integrated, and installed on the road surface. The strip accommodated a series of CITS applications from cooperative safety to road predictive maintenance. We will hear more about the strip and its features in the next video.
SafeStrip is developing a cost-efficient and energy-sustainable technological solution which supports and improves CITS applications through low-cost integrated strips installed on the surface of existing traffic lanes. These strips will integrate micro and nano sensor modules for vehicle identification, road deformation detection, temperature, humidity and gas sensors, as well as communication and energy units. This is to capture and convey real-time environmental and traffic information in a dynamic way. The power supply of the sensors comes from collected ambient energy. A series of piezoelectric, photovoltaic and RF harvesters, along with batteries, are integrated inside the strip to provide power through renewable energy sources. It supports energy harvesting technologies, which provides at least 20% of the consumed energy. Equipped, including autonomous vehicles, will receive personalised information and warnings through an onboard HMI, whilst non-equipped vehicles and motorcycles will be reached through mobile devices that will assist driving.
Seven application families have been selected to prove SafeStrip concept, encompassing applications for drivers and riders, road predictive maintenance service for operators, and various functions for automated vehicles. One of the most innovative research items has been the friction estimation module. It combined tire sensor data and environmental information communicated through the strips. The local dynamic map of ITSG5 has been used and extended to sense any vehicle and pedestrian at specific location and lane level, allowing also implementation of personalized applications. The solution and applications have been evaluated in 4 rounds, the last 2 of them being user trials in real traffic conditions, with 7 demonstrators provided by project partners and at 3 different sites. In Spain on Sidaut test track, on A22 motorway in Italy, and Atiki Odos motorway in Greece. The solution was replicated and with some of the demonstrators sent back and forth between the sites for the evaluation. System and driver performance results provided high value, especially when LTE did not interfere, at least for the safety applications. The applications were highly accepted. In most cases, standardization and improvement of robustness have been the key issues for the further exploitation. Virtual VMS and toll stations applications, which SafeStrip aims to replace, were considered as the most promising and closest to the market solutions. As far as the impact assessment is concerned, we can specifically mention the reduction of investment and exploitation cost of up to 90% compared to current systems, as the impact assessment of the project confirmed. Impact assessment was based both on subjective data, system and driver performance data logged across several ends of the system, as well as in the further microsimulation work. It also proved great gains for parking operators, as well as life cycle savings of about 30% due to the road predictive maintenance functions. In more detail, when we look at the same safety and impact, significant reduction of injuries due to accidents avoided, or at least due to the reduction of their severity, is also proved, especially for the roadworks and cooperative safety functions at given penetration rates. Traffic efficiency-wise, it also proved to lead to higher mean speeds, lower traffic density, and higher traffic volume, improving the overall efficiency. Impact on environment. All applicable functions may also lead to reduction of greenhouse gas emissions and lower fuel consumption, with roadworks and parking applications achieving the greatest benefits. Finally, cost-benefit analysis demonstrated that the benefits are greater than cost in most cases, we can see in green on this table, apart from the VRU functions, whereby the cost of equipment for all pedestrian crossings would prevent a positive overall outcome. How we see the future. SafeStrip can be exploited through several business cases, ranging from deployment on permanent basis, from nationwide to temporary targeted installations for specific reasons. Current TRL of the integrated key solution is between 6 and 7, though infrastructure owners and public authorities would play the decisive role to ensure the final exploitation of the SafeStrip solutions. Furthermore, about half of the emerging products would be in the market between 1 to 2 years from now, whilst one of the crucial aspects in allowing European-wide deployment is a thinner strip integration, allowing adherence with the stricter protrusion standards. Apart from linear integration approaches, follow-up research would focus on alternative low energy harvesting solutions, further research on dynamic friction and smart tires, targeted applications for CCAM, and deploying alternative vehicle detection and identification approaches. Specifically, follow-up research is already taken in existing initiatives, whereas exploitation would be mainly driven through the industrial and SME partners. Optimization, targeted business plans and demonstrations, cross-checks with OEMs' roadmaps and standards, and of course, further and wider testing needs to take place prior to commercialization. I thank you very much for your attention. You're welcome to download all of our public documentation and public deliverables on safestrip.eu website, and also the media pack in our library. Please follow us on the social media too. Thank you once more.